Okay, so we're going to learn about conditional probability. So these are probabilities with some very specific conditions. So we're going to solve problems using probabilities. Okay, so first we're going to get through the boring, just vocabulary stuff. So given events A and B, conditional probability is the probability of event B occurring knowing that event A has already occurred. So this is different than what we have been doing. So here's some weird stuff. So here's what this looks like. It's going to look like the probability of B. This straight up and down line, anytime you see that, means the word given A. So this, anytime you see it, means given. So it's something you know has already happened. So we're going to read it as the probability of B given A. Okay, and then there's a formula for it. So anytime you want to find the probability of B given A, it's going to be the probability of A and B happening at the same time divided by the probability of A. So notice the thing that's given to you becomes your denominator. So what is given becomes the denominator. And that's very different than what we have been doing, because usually it's out of the total number of possible outcomes. This time that's not what's happening. Okay. So here's an example. Mitchell drew a card from a standard deck of playing cards. Standard deck of playing cards always has 52. What is the probability that he drew a queen given that the card was red? Okay, so we are told that the card is definitely red. Out of 52 cards, 26 of them are red. Of those 26 cards, 2 of them are queens. So our answer is 1 out of 13. All right. All right, number 2. A number selected from 1 to 100 is randomly selected. What is the probability that it is a perfect squared given that it is an odd number? So, out of 1 to 100, there are 50 odd numbers. Alright, so now we're going to think about all the odd numbers that are perfect squares. Or let's do this. Let's list out all the perfect squares. So 1 times 1 is 1. 1 is a perfect square. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 100. But we want to know how many perfect squares are actually odd. 1, 2, 3, 4, 5. And if I reduce 5 over 50, I get 1/10. My answer is 1 out of 10. Alright, this one's a little weird for people. There are 62 people that take a yoga class, and there are 48 people that take a spinning class. 15 people that take yoga also take spinning. Alright, so the first thing I'm going to do is I'm going to draw you a little diagram. And it's going to be a Venn diagram. Hopefully you learned these. So these are going to be my people that take yoga. These are my people that take spin. Okay, so 15 people take both of them. There are 62 people in total that take yoga. 62 minus 15 is 47. So 47 just take yoga. There are 48 people who take spin. 15 of them also take yoga. 48 minus 15 is 33. Okay, so you have to understand how to do this. If a person from the group is selected at random, find the probability that they take a yoga class if you know they take spinning class. So my bottom number is the people who take spinning class. There are 48 people that take spinning class. And there are 15 people that take spin and yoga. So 15 out of 48, which you can reduce. So my answer is actually 5 out of 16. Alright, so I want you to read this one, and I want you to see if you can make the Venn diagram, because I think that's the hardest part. Okay, so there are 30 students in total. Alright, 13 are athletes, and 9 are in band. 3 of the athletes are also in band. So I want you to see if you can fill out the Venn diagram. So try that in 1, 2, 3. Okay. So 3 of the athletes are also in bands. This is how I'm getting 3 right here. There are 13 total athletes. 13 minus 3 is 10. There are 9 total people in band. 3 of them we know are athletes. 9 minus 3 is 6. So this is how I'm getting this. Now I'm going to find the probability that the student is in band, knowing that they are not an athlete. There are only 6 people who are not athletes. And we know that they're in band. Sorry, not 6. Okay, so let me try this again. There are 30 students total. And we don't want any of the athletes. So there are 13 total athletes. That means 17 are not athletes. Out of those people, 6 of them are in band. So that's how I get 6 out of 17. And it doesn't reduce, so we're good. Okay. So one thing that's very big on the ACT and on the NC final exam for Math 2 are these things called two-way tables. So a two-way table is a table that records data that pertains to 2 different categories. Number 1, the table shows the result of a poll of 50 randomly selected students, so I know there's 50 total, who were asked whether they prefer to watch hockey or football. Now we're going to find the probability. So remember that number, part A is red. We're going to find the probability they prefer football given, because remember that's that straight up and down line, they're a girl. So first I need to figure out how many girls do you have. You have 6 and 16. So if you add that together, that's 22. So out of 22 girls, now we're going to look at how many prefer football. And there are 6 of them. So 6 out of 22, which reduces to 3 over 11. Part B says we're going to find the probability that they're a boy given they prefer hockey. So my bottom number is going to be the people who prefer hockey. So that's 10 and 16, which is 26. Out of those 10 and 16, there are 10 boys. And that reduces to 5 out of 13. So just remember that the part after the given sign is your bottom number. The part after the given is the bottom number. Alright, so if you look at number 5, notice that part A is not conditional because it doesn't have that given line. So we want to find the probability that there's a 7th grader who takes French. So 7th graders who take French, there's 25 out of the total number is 150. And then I can reduce that to 1 over 6. Alright, so for part B, I know my bottom number are the people who take Spanish. I'm going to add them all together. There are 68 people who take Spanish, and I want the probability that they're an 8th grader. So out of the ones I just highlighted in green, there's only 33 who are actually 8th graders. And that doesn't reduce, so that stays. Part C, I want to find probability that they take French, given that they're a 6th grader. So my bottom number is going to be all the 6th graders, which if I add that together, I get 42. Out of those 6th graders, 19 of them take French, and that doesn't reduce. All right, and then the last one, we want the probability that they're a 7th grader, knowing that they take French. So I'm going to add up all the people who take French, 125, and out of those, not 125, got ahead of myself, that's 82, try that again. Out of those 82, there are 25 7th graders, and that does not reduce. Okay, so that's how you read these. So whatever your given is your bottom number. All right, number 6. The table shows the result of a poll of a randomly selected juniors and seniors who were asked if they attended prom. We want to find the probability a junior did not attend prom. So this has nothing to do with conditional probability. This is just regular stuff. So there are 56 juniors who said they did not attend prom. And if I add all the juniors and seniors up, I get 200. And that reduces to 7 over 25. Alright. Next I'm going to find the probability they did not attend prom, given that they were a senior. So I got to add up all the seniors. I get 116. Out of those seniors, 19 did not attend prom. And that doesn't reduce, so we're good. C, I want to know the probability that they're a junior, knowing that they attended prom. So these are my people who attended prom, and I get 125. Out of that 125, 28 of them were juniors. And that doesn't reduce. So that's how we do those problems. Okay, so I want you to try this EOC problem. A total of 540 customers who frequented an ice cream shop responded to a survey asking if they prefer chocolate or vanilla. 308 customers preferred chocolate ice cream, 263 were female, and 152 were males who preferred vanilla. So I want you to make a little two-way table. We're looking at males and females, and then we're looking at if they prefer chocolate or vanilla. So I want you to pause the video, and I want you to see if you can fill out the table. There's enough information in here. So pause the video, fill out the table in 1, 2, 3. Alright, so we know that there are 152 people who are male who prefer vanilla. I know that there are 308 people who like chocolate in total. There were 540 altogether. So if I do 540 minus 308, I know that 232 like vanilla. I know out of that 232, 151 of them were male. So if I do 232 minus 152, I get that 80 are female and they like vanilla. I know that there are 263 females in total. So if I do 263 minus the 80 that like vanilla, I get 183 that like chocolate. 308 people like chocolate. So if I subtract the females that like chocolate, then I get 125 males that like chocolate. Okay, so what is the probability that a customer chosen at random is a male or prefers vanilla ice cream? So here are all the males, or they could be a female that prefers vanilla ice cream. So if I add up all three of those numbers, I get 357 out of 540, and when I reduce that number, I get 119 out of 180. Okay, so anytime you encounter a problem like this, you need to make a little two-way table, and then you answer it. It's a little confusing, but it's just simple math. Okay, so this one's kind of hard. We're going to talk about frequencies. There are two frequencies we'll talk about. Joint relative frequency, this one right here, the values in each category divided by total number of values, and then marginal relative frequencies, found by totaling each row and column. So if I look at number 7, I'm talking about the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. So if I look at this first table I'm given, the first thing I'm going to do is I'm going to add them all together. And I see that I get 160 total. So that's just something you have to know how to do. Alright, so when I do 2 bags first class, I get 16 out of 160. And if I put that in my calculator, I get 0.1. The next one would be 52 out of 160. And when I put that in, I get 0.325. Alright, so what I'm doing is I'm filling out my joint relative frequencies. So just to save time, now you know how I'm getting those numbers. I'm just going to go ahead and put them in. Alright, so those are my joint relative frequencies, and now I'm going to do my marginal ones. So this is going to be the ones in purple. I'm just going to total up the rows and then the columns. And I'm just getting these by adding down, adding across. And anytime I do one of these tables, my very last number should always be right here at 1. If you didn't get 1, you've done something wrong. Oh, I thought that was going to slide up. It's not. Okay, I'm just going to leave it like it is. Okay, so probability A, I want a coach class passenger that did not check any bags. So coach that says no bags, you can just read the table, 0.1125. And then this can also be changed to a percentage. So remember, you move the decimal place over twice. Alright, so for part B, a first class passenger that checked at least 1 bag, that means they could have checked 2. I'm going to add, let's see, 0.1 and 0.075. So I get 0.175, which is the same thing as 17.5%. Alright, C is my conditional probability. I want a coach class given that they checked 1 bag. So the amount of people who checked 1 bag was 0.45. And out of those, the people who were coach were 0.375. And if I put that, I get 0.8 with 3 repeating. So that's the same thing as 83.33%. And the very last one, probability that they checked 2 bags given they were first class. There are 0.1875 first class. Out of those, the people who checked 1 bag were 0.1, which gives me 0.53 with the 3 repeating, which is the same thing as 53.33%. Okay, so we did that. And now we're going to look at an EOC problem. So I wanted to see if you can make a two-way table. So I want you to pause the video and try this in 1, 2, 3. Okay, so here are the things you're comparing. Okay, so I'm going to start with the last one first. Brittany chooses the bus 80% of the time, so I'm going to do 0.8, which means she chooses the train 20% of the time. Okay. The probability of the bus arriving late is 33. the probability of a train arriving late is 10%. So this is a little weird to explain. So the train arriving late, 0.1. So that means the bus arrives on time 67% of the time, and the train arrives on time 90% of the time. So what I'm going to do is kind of like a Punnett square, if you've ever taken biology. I'm going to multiply these two together to get this value in here. And then I'm going to multiply these two to get this value. So I'm multiplying it like I would a Punnett square. If that doesn't make sense, just let me know and I'll explain it further. So I'm going to fill out this chart. Okay, so now I have this information. And I want to know, what is the approximate probability that Brittany took the bus given that she did not arrive late to her destination? So she definitely arrived on time. So I'm going to add those together. And I get 0.716. And then I want to know, what's the probability she took the bus? So 0.536. So I'm going to put that in my calculator. And you can hit, well, no, you don't have to hit Math Enter, but you get 0.7486. And if you remember rounding, we're going to round to 2 decimal places, so it actually is B. I know that's super hard and confusing. Okay, so what I want you to do is I want you to look at this problem, and I want you to answer the next problem and model it the exact same way. So I want you to make a little chart for Jamal, and then we're going to answer it in the exact same way. Okay, so here are the things we're looking at. Jamal uses the bus 60% of the time, which means he uses a taxi 40. When he uses a taxi, he gets home after 7, 8% of the time, which means 92% he gets before. When he chooses the bus, he arrives home after 7, 15% of the time, which means 85% of the time he gets home before. So now remember, I'm going to multiply these two numbers to get, sorry, not that, those two numbers. And I get 0.032. And now I'm going to multiply these two numbers to get the next one. 0.368. And now I'm going to multiply these two numbers to get 0.09, and then I'm going to multiply these two numbers to get 0.51. So that's how you make your little, it's like combining a two-way chart and joint and marginal relative frequencies. Super confusing, I know, I'm sorry. So what is the probability that Jamal gets home from work by bus given that he arrives after 7? So these are all the ways to arrive after 7. So if I add those, I get 0.122. Out of that, I want the probability that he went by bus, which is 0.09. And so I'm going to put that in my calculator, and I can round to 0.74. Super confusing, I'm sorry. Alright, so I want you to try the problems on your practice problems and then let me know if you have any questions.